Section 2.6, combining transformations. So we need to know what are the transformation and combining a few transformation together. So three main words we discuss on this. One is translation, and the other one is stretch, and the other keyword is reflects. Translation. Uh, if we There are two type of translations. Basically, a graph. If we move along x-axis, or if we move along y-axis. So this is going to be a translation. And stretch. If we multiply, uh, okay, I will tell like this. Two types of stretch: vertical and horizontal. Vertical. Okay, I'll write horizontal first. And vertical. And reflects two types: y-axis, x-axis, and y-axis. So we'll consider this one first. Translation on x-axis. So if this is fx, the graph is fx, then you can see fx plus 2 or fx minus 3. Those are two examples. It means you are moving a graph along x-axis. Assume this is the graph fx. Now, what is fx plus 2? Fx plus 2 graph is, the technique is we write x plus 2 equals 0, x equal minus 2. It means 2 units. I want to bring this curve to left side. So assume this is 5, 4, 3, 2, 1, 0, something like that, and 6, 7, 8, 9. So if x plus 2 mean what we need to do. So we write x plus 2 equals 0 as a technique. So x equal minus 2. We want to bring 2 units to left. So we will write this one as a vector minus 2. We know we write vectors x and y. So then 2 units to left and no movements on y. So we can write in a vector form as well. Then the graph is going to be same as, so this is the graph. I draw a line. So this line, each and every point of this line, not y, x values, has to shift 2. So for example, this point is uh, 5, 0, this point, and I want to shift 2 units, 1 and 2. Now this point is here, that is 3, 0. Y value is same. Then if you take this point is A, B point, then I want to bring this point 2 units. Then A become A minus 2 and B is as it is. So I'll draw the graph and this point. So this height is same. We don't touch y values. So b a minus 2. 2 in its left. So this is fx plus 2 graph. And this is fx graph. And this one fx minus 3. So then x minus 3 equals 0, x equal 3. It means 3, 0. No y movements, only x movement, 3 units to right. Then this the original graph, which is fx, I have to shift 3 units. All the x values of this graph, so all the x values of this point should be shifted by 3 units. For example, if I shift this 5, 0, then 5 plus 3, 8, 0. So they all should be parallel. So for example, this point, so I shift 3 units to this, but the y height is same. This height is same still. If you select this point, 3 units to right, and this height is still the same. It means it is only affecting to x, not y. So this is one type of translation on x. Now this is the original curve. We want to do fx plus 2. Then what do? We have to shift original graph by 2 units to left. So 2 units to left. Fx is the original graph. Fx minus 3. What we need to do? We have to shift 3 units to right. So we will write this is minus 2, 0, and this is 3, 0. So this is the summary. You will see that if this is positive value, we are going to left, and a negative value, we are going to positive side. So done this one. If x plus c and f x minus c form. Now we'll discuss this one. Translation on y-axis. It means here we only change along x-axis affect to x values of the graph. Now it is y values. For example, if we have let's say graph like this, quadratic graph, and let's say this is 2, 0, 2, 4, x value is 2, y value is 4, this height, and this is fx graph. Then fx, what is fx plus 2? It means we have to shift. Now we have points. Points mean lots of coordinates, infinite number of coordinates, and all the y values we want to shift by 2. Basically this graph we want to shift up by 2 units. So then it is effect to 2 or 4, because we know that 2 is x value and this translation on y, so it should not affect to x values, it should only affect to y values. This 2 become x equal to as it is, and we want to add each and every y value to 2 by 2. So 4 plus 2 is 6. Then this point is now here. The graph is something like this. So this point is 2, 6. Now you can see that I shift 2 units up from here. Here 4 plus 2, 6. So fx minus 2 or fx minus 4. What is the command is given? Bring all values of y values by 4 units down. So now this is the fx original graph and you want to bring 4 down. It means this one. This is going to be 2, 0. Why? 4 minus 4. The original one is 4 y value and 4 minus 4 is 0. That's why it is 0. Likewise, you have to bring each and every point down. This point also 2 units down. This point also 2 units down. So, and when you merge those points, you will get the curve. Now, we know the vector form is xy. Now, we don't touch x here. So, x value is 0 and y we put plus 2 for this one. So, x we didn't touch and minus 4, the translation. 4 units down from the original y values. Summary is if we have a fx graph, translation on y-axis, um, and if we have fx plus 2, then we have to move 2 units up, so 0 to vertical as a vector. Fx minus 3, it means we want to move 3 units down the original graph. Each and every y values we have to bring down with 3 units. So this is 0 minus 3. So now this is horizontal um, and this is vertical basically. So this is horizontal push and pull. This is vertical push and pull. Now horizontal push and pull and the horizontal stretch. We'll discuss now the 3 horizontal stretch. It's like this. Assume this is a circle and if we want to, we'll keep the same. Yeah, this is the same, and we can bring into this form, or we can bring this circle into a ellipse form. When you look at this from here to here and from here to here, the y values is going to be same. The x values is moving. For example, assume this is unit 4 and this is 8. So I'm only consider 2 points only, but we have to consider all the points. And this is fx graph. Now, when it's come to f2x, so this point 40 and this point is 80. When it's come to 2, we don't multiply by x value to like 2 times 4 equal 8. That is wrong. So the way it works, the opposite way. If it is 2, so we want to halve all the x values of this each and every point. So if you look at this point, there is a x value. If you take this point, so there is a x value. So those x values you need to halve instead of multiplying. If it's 2, so for example, this 4 over 2 become 2. 8 become 4. So then this is, let me see, 4. If this is the y-axis, now instead of 4, 0, the new point is 2, 0. Instead of 8, 0, new point is 4, 0, this one. So likewise, y value is going to be the same. So considering only those 2 points, I can see that the circle is going to be something like this. So this point, this x value, when you halve, you will get this one. Now you can see here, what is the radius? Diameter 8 minus 4, 4. What is the diameter here? 4 and 2, that is 2. So we can't tell this is the diameter, actually it's the distance between those 2 points. So those 2 points it is 4, between those 2 points it is 2. So that's how we squeeze. Basically, when there is a multiple of this value, more than 1, the original graph is squeezed by 1 over of this time. We can explain in a proper words. So all the x values of this graph we have to multiply by scalar factor of half. Multiply by scalar factor of half. The same idea that all the x values divide by 2. We will tell it a different way. Multiply by scalar factor of half. What will happen? Graph is f1 third x. So now it is not squeezing, it is a stretch. I can write like f equal x divided by 3 as a division. Now we know that when it is a multiple, we divide all the x values. When it is a division, we have to multiply all the x values. So you can keep in your mind like that. You can remember like that. For example, this 4, now we have to multiply by 3. So 4 0 point transform into 4 times 3, 12 0. And 8 0 point transform into 8 times 0, 24 0. It means this is 12 0, 12 is somewhere here, and 24 somewhere here. So in that case, it's going to be something like this. So this is f, let's say ax and f, x divided by a. Now you can see that with the x-axis, all are opposite. If it is plus c, you want to bring shift to c to left and minus c right. Likewise, multiple a, if you see, then you have to divide the x values. And if you see division, or this is same as f1 over ax, then you have to multiply by a. We have to do the opposite thing. But with the vertical, with the y-axis, push or pull, it's follow the sense basically. If it is plus 2, fx plus 2, you shift the graph by 2. If it is minus 2, you bring 2 down. So it's go with the sense. So this will work opposite of our sense. We expecting plus, but the graph is shifting to left. We expecting multiple A is, but instead of that we are dividing. We'll discuss number 4, vertical stretch. Um, so now this circle, so this is the same circle, let's say 4 and 8. Now it is going to be vertical, and if this is fx, now fx 2 times fx. So what will happen? This each and every point, it has x and y values. So y values we double. Assume this is 4, 6, 2. This is 6, 2. Okay, 6, 4. And this is 6, 0. Then OR2, this is 2 and minus 2. Then double this one. 2 times fx. Then all the y values. So I only considered a 2 point, minimum and the maximum, max and mini. So y value. So this is 2. Then 2 times 2, 4. So this point is here now. 6 and 4. And what will happen? Minus 2 times 2, minus 4. 6 minus 4. Now this circle is become something like this. And it will follow the sense, multiply the y values. We know all verticals is affected into y values. So multiply all the y values by 2. If it is half a fx, what shall we do? We have to, this is same as fx divided by 2. So we have to half of it. So then this 2 point become 1. Half of 2 is 1. So it is going to be 6, 1 here. And minus 2 become minus 1. So it is here. Then this point is going to be something like this. This graph. This is fx. This is f2x. This is f, I think I draw 1/3 x. And this is fx, this circle. This is fx times 2. And this one half fx, the small rugby ball. And number 5, reflection of x-axis. Assume that the graph is fx, and if you see minus fx, so this is a reflection of x-axis. Assume this is the graph. This is the graph. So this is the x-axis. Then the reflection For this part, we have to keep the mirror here. Then this is its reflection. And for this part, when we keep the mirror in other side, so this is the shadow of this one. So this is fx, and this is minus fx. So what is the command given here? All the y values of the graph multiply by negative. So we know that this is look like 4, 5. So this is positive 5. Multiply by negative, it's become negative. So 4 minus 5. So this point. And if you look at this point, this is, let's say, minus 20, minus 7. So then multiply by this value by minus. Then it will become this point here minus the positive 7. So the command is given, switch all the y values, negative to positive, positive to negative. That is what happened then, minus fx. And number 6, if you see f minus x, this is on y-axis, reflection of y-axis. For example, assume we have a curve like this. Then this is fx. Then minus fx, f minus x. So we have to bring a mirror in this side to get this part done. So and we have to keep the mirror here to this part done. So this is on y-axis mirror reflection. Now you can see that to get this one, I kept the mirror in this side, and to get this side, I kept the mirror in, but it's still in the y-axis. And earlier also still in the x-axis. But in the previous section, we discussed something like this, fx mod fx and f mod x. So in this case, we only keep the mirror in one side. For example, if this is the graph, um, something like this, then we keep only the mirror in one side to make all the y values to positive. So here we keep both sides, but in here only one side. And same as f mod x. If we have a curve like this, original curve, um, so then here also we keep only one side. So we disregard this side and we keep the mirror in one side, and we'll get the mirror reflection like this. So this is the difference. So only mirror keep in one side even when we consider reflection, but in here we keep the both side on y-axis, and number 5 both side on x-axis to draw the graph. So we'll discuss example 20 and 21 in part B.